Hello, um, good day to all my fellow students in my grad for Math 204 Foundation or Structures of Modern Math. So this is a continuation that I gave to you. So last time we defined tautology, uh, if I can recall. So tautologic statements and its logical implication, tautology and contradiction. So as a continuation, we have a relation in proportion defined by here in this theorem. Proposition implies Q is a partial order that is reflexive, antisymmetric, and transitive. And another theorem, if P implies Q, then for any proposition P sub 1, P sub 2, and so on, P implies to Q with its corresponding proposition also. Logically true and logically equivalent statements. A statement is logically true if it is derived from a tautology. A statement it is raining or it is not raining is logically true since P or not P is a tautology. Kanang union is or mana. So true or not true is a tautology. True or not true? Nalimot na biya ako actually class. So let's check. True. Yeah, correct. True or false is just true. Okay? So we are correct there. Two statements P and Q are said to be logically equivalent if the propositions P and Q are logically equivalent. Consider the two statements. It is false that roses are red and violets are blue. Roses are red is true, violets are blue is false. Okay? So true and false is what? False, diba? So it is false. Roses are not red, this is false, or violets are not blue. So what are those? False or true can be logically equivalent, no? So false na siya. Roses are not red, this is false. Violets are not blue, this is true. So false or true can be true. Okay? So 1 and 2 are logically equivalent. This implies that not P or Q is logically equivalent to not P or not Q. Okay? So 1 and 2 are logically equivalent. For quantifiers, we have proposition, function, or simply an open sentence or condition on A is an expression denoted by the proposition which has the property that the proposition A is true or false for each A element of A. For example, let A be a set of all positive integers. The following are open set. Take note that for the proposition given is x plus 2 greater than 7, and the proposition for our second example, the proposition is square root of x less than 10. If the proposition is a propositional function on a set A, then the set of all elements, A element of A with the property that the proposition A is true is called the truth set of the proposition. Example, let A be the set of all natural numbers or countable, capital N. Find the truth set of the following open sentence on A. So for number 1, The given here is x plus 5 lesser than 20, and then x minus 7 lesser than 11. So the truth set for number 1 until n is a countable man. So we consider only 1, 2, no? So until 19. So the set here is 1, 2, and so on up to 14. Okay, 14 plus 5 is 19 man. Okay. And the second example, what will be the set here? X minus 7 lesser than 11. So kinanglan kuto bratag 10, no? So the set here would be what? 1 up to 17. Yeah, correct. 1 up to 17. Okay? So ayan gibuhat una, ayan gibalhin ning minus 7 sa pika, so 18. So x lesser than 18 muna ang kuan. Now there's an assignment here, but the problem here is nawala atong akong libro nga should be the source of this text, foundation of mathematics. So sayang ka ito, so I need to avail it by Shopee dagway. Basta na to Shopee. But sadly to say, wala na may kuan dili. Unlike there sa Bacolod or kuan sitaw ganing National Bookstore, no? So sa Shopee, anyway sa ang Shopee na National Bookstore, hopefully makita ko to. So let's proceed. Universal quantifier. Let the proposition be a propositional function on set A, then for all, okay, universal na siya, for all, for every x element of A in a proposition. Okay, the symbol for which is for all or for every is called the universal quantifier. Example, let M denote all men, then all men are mortal. Can be written for all x element of M, then x is mortal. For its property, if every x such that x is element of the set A in a proposition, then it is equal to A, is true. If the set x is an element of A not equal to A, then the given proposition at any given x is false. Example, determine the truth value of the following. Okay, let n be the set of counting numbers. So our proposition is n plus 4 greater than 3. Okay, therefore bisag 1 sulod gyapon, no? 1, 2, sugod tag 1, pahibo naman siyang 5, so sulod gyapon siya. So therefore the proposition or the truth value of the set is true. How about number 2? Niyon man siya false. Why? Kaya atong set is the set of all counting numbers man. Kay for all good, so musugod yung tag 1. Take note that 1 plus 2 is 3. So 3 definitely is lesser than 8. So false na siya na. Okay? So not equal to the set of all counting numbers. Then we have existential quantifier. Let the proposition be a propositional function on a set A, then there exists an element of A in every proposition. Okay, kanang bali nga muna siya kitawag there exists, no? For at least one or bisag adunay isa. Okay, is called an existential quantifier. For every property, if the set X, an element of X in the proposition is non-empty, then there exists X in a proposition is true. If it is empty, then the element of X of the proposition is false. Example, determine the truth value of the following statement. There exists n element of n such that n plus 4 is greater than 7 or lesser than 7. Aduna by elemento sa atong counting number. Aduna, no? So, by looking at this alone, number 1 is true. And then, number 2 is what? Number 2 is false. Kaya musugod tag 1. 1 plus 6 is 7 na daana. 7 is greater than 4, not lesser. Okay? So, nakita nito dire. 1 is true, non-empty. And number 2 is empty. The negation of the proposition, if for all x element of A in a proposition, ang negation na niya would be there exists x in a proposition, and then we negate the proposition at the same time. And then the negation of for some, okay, x element of A in a proposition is logically equivalent to for all x element of A, and then a negation of the proposition. Example, write the negation of the following statement. For all n element of n, then n plus 2 is greater than 8. And then number 2, there exists a habitable planet. Okay, take note on number 1 first. For all n element of n, n plus 2 is greater than 8. So, unsa may negation ani? Pag i-negate nimo ani for all, may mo siyang there exists, no? Okay, so kita na dire. As a counter example, ang negation sa for all is logically equivalent to there exists x, and then not the negation of the proposition. Okay? So, to do that, we consider an element x sub 0 with a property that once we apply it on the proposition, ma-false siya. Okay? So, you call that one counter example. So, mga tag counter example class, and then mo fit na siya, no? So, example, in our proposition, n plus 2 is greater than 8. Okay? So, ang negation niya, balihon na nato ng inequality, no? Greater than, ang bali niya is lesser than or equal. Now, for all x element of the counting numbers, for our proposition, ang negation niya would be there exists n element of n, and then the negation of the proposition is n plus 2 greater than 8. So, ngayon tadre, there exists an n element of n such that kani iya rin state, no? Such that ang yung negation sa proposition is n plus 2 lesser than 8. Okay? So, from a false statement, okay, iyang gi-prove by counterexample. Okay? Take note. So, kani, this is already a false statement, no? So, good tag 1. So, false na daan. So, to prove that, iyang gi-prove by counterexample. Kani, there exists a habitable planet. Okay? So, our proposition is x is a habitable planet, no? So, ang iyang negation sa proposition is not a habitable planet, no? So, ang negation sa there exists is for all, no? For all x and then not p. So, kani, this is a what? There exists a habitable. This is a true statement. Okay? So, ang negation ani would be the result. So, kita na to dire is logically equivalent to for all x and then not the proposition. So, all planets from for all, no? So, yun siya, all planets are not habitable. Okay? From a true statement, ay mo na siyang false statement. Prove the following by counterexample. Okay, so for all x, an element of x is not equal to 0 is false. Okay? na for all x, x squared is greater than x is false. Okay? Nga naman siyang false. Nga na po ding false din number 2. Okay? So, let's say example 2. 2 squared is 4. 4 greater than 2 manta. Okay? Here, may ka 1. 1 is not equal to 0. Nga naman yung false. Okay? So, take using the counter example, you have here not for all x, not such that x is not equal to 0. So, ang for all, kung i-negate na to na, that is, there exists. Okay? There exists such that the negation of this one is equal to 0. Such that x is equal to 0. Take x equal to 0. Okay. How about x is equal to 0? Observe that the absolute value of 0 is 0. Diba? So, this shows the claim. Accordingly, for all x, the absolute value of x is not equal to 0 is false. Okay? So, how about kung 0? Tinood man, diba? The absolute value of 0 is equal to 0. Okay? In here, no? Kaning number 2. Anong false man yan eh. So, take the negation of the proposition which is x squared. The negation of greater than is lesser or equal to. Okay? So, for all, ang negation sa for all is there exists and then the negation of p. So, there exists x such that x squared is, the negation of p is x squared lesser than or equal sa x. So, how about x 1/2? Take note that 1/2 squared is 1/4. Okay? Which is lesser than 1/2. Okay? So, this shows that x squared greater than x is false. Okay? Wala man ingon diri nga dili pwede ang rational. Okay, rational q, no? Q. Rational number is represented by capital Q. Okay, so how about 1/2? Okay, so false na siya. Okay, so muhunong ko diri and then I proceed to methods of proof.